Hey guys, I wanted to put together a video that goes through the questions on the Intro to Probability quiz. I know that some of you did really well and others kind of struggled with it, so I just wanted to take a few minutes and work through each of the questions and show you how I would do it given the formulas that I have that are given to me in the formula packet. And so hopefully this is helpful. Feel free to skip around and look at the questions that you missed or just the things that you weren't able to figure out. So yeah, here we go. Question number 1. For two events, x and y, p of x equals 0.7 and p of y is 0.5, and p union of x union y equals 0.9. Find the probability of x and y. Now, a lot of you, unfortunately, on this question went straight to multiplying px times py. Now, that caused a couple of problems. Number 1, you get the answer wrong. You get the answer wrong because that only works if these two events are independent, and it does not say that it's independent. The other problem that comes about is in part C, when it says determine whether they are independent, you already forced them to be independent by using px times py up here, which means you probably lost points on C as well. All right, so what you need to do here, because it's not independent, you have to use a formula that will allow you to solve for that intersection. And that is the one that's given inside the formula packet that looks like this. The probability of x union y is equal to the probability of x plus the probability of y. I think it's a's and b's in the formula packet, but you get the idea. Minus the probability of x intersection y. Okay, so now we can put in the value. This works all the time. And so we can put in the values that we have. We have probability of x, we have probability of y, and we have the union, which allows us then to solve for the intersection. All right, so we're going to go ahead and put the probability of x in, which is 0.7, the probability of y, which is 0.5, and then intersection, and then of course I have the union, which is right there, 0.9. Okay, so I add these two together, subtract them to the other side, get rid of the negative, and what I end up getting is 0.3 equals the probability. I did skip a couple of steps there just because I feel like the algebra part of it you can get. I just wanted to show you that's the formula that you want to use in order to be able to get the probability of x and y. All right. Part B now asks us to find the probability of x given that y is true. So in your formula packet, it gives you the probability of A given that B is true, and that is the probability of A and B divided by the probability of B, the given thing, the thing on the bottom. All right. So in this case, we can go ahead and say that A given B is the same as if we make A x and B y, which is what it wants here, then you should be able to do probability of x and y, which we just found, so that was 0.3, and then divide by the probability of B, which is the second thing, so the probability of y, which is given to us as 0.5. And so we do that, and we get our answer of 0.6 is the probability of A given B. All right, now letter C says determine whether x and y are independent events. All right, so there's a couple of ways to go about this. One is you can say, well, if x and y are independent, then px times py should equal the probability of x intersect y, like that. And so then you can test it out and you can say, well, that means 0.7 times 0.5 should equal the intersection, which we found, which was 0.3, and that obviously is not correct. That gives us 0.35 equals 0.3. And so then we should say, since, and you should actually write this out, I'm not going to write out because it'll take me a little longer, but since these two things are not equal, the independent function is not correct, therefore these two functions are not independent. Another way that you could do this one is you could say, well, if they're independent, then the probability of x should equal the probability of x given that y has happened, right? Y happening should not affect x if they're independent. And we look at the probability of x, which is 0.7, and we look at the probability of x given y, which was 0.6, and we say, oh, those are not the same. Again, you need to write that explanation saying, because the two should be equal but aren't, therefore they must not be independent. And so that's the answer to number 1. One thing that I want to make sure to mention is a couple of people, not actually several people, mixed up mutually exclusive and independent. Okay, these two things are different. Mutually exclusive means that there is no overlap, right? If there's no overlap, then the things are very dependent on each other, because if you do A, then you cannot do B, right? Then that's very dependent, right? And so you should be careful. If it says independent, you should be looking at the two things that we looked at here, either this one or this one. Mutually exclusive is, if it's mutually exclusive, then the intersection should be equal to 0. All right. So hopefully that will help in the future. Make sure that you work with that. All right. Moving on to question number 2. Most people got this right, so I'll go through this fairly quickly. Let's see. I think I need both A and B here. There we go. So the tree diagram was pretty easy. You just put in the values. So these had to add up to 1, because when you split, those two should add up to 1. Then it says the probability that if he buys a new bike, the probability that he wins is 0.8. So the new bike, this would be 0.8, which means, again, these two, because those two have to sum up all of the probabilities of the new bike, this has to be 0.2. And then if he does not have a new bike, the probability that he wins the race is 0.4. So this is 0.4, which means this one has to be 0.6. Right? Again, those have to add up to 1. And so then you find the probability that Matthew wins the village cycle race. And so that would be any path where he wins. So that would be this one, which would be 0.7 times 0.8. And then also this one right here, the 0.3 and the 0.4. So 0.3 times 0.4. Anytime you choose things along a path, you then multiply those, and then we're going to add these two together, so we get 0.56 and 0.12, which gives us 0.68. And like I say, most people got that one right, but wanted to make sure that we had the complete quiz here. All right, let's move on to question number 3. Nigel has 3 black socks, 4 red socks, and 6 white socks in his sock drawer. He reaches in and pulls out a sock at random. Write down the probability that the sock is white. Most people got this one all right, because they added up the socks. There were 3 black, 4 red, and 6 white, which adds up to 13 total socks. So 6 white out of 13. And so that was a pretty easy one to start with. Nigel puts the sock back in the drawer and pulls out 2 socks at random. Okay, so note he puts that one back in, whatever it was. So now he's back to 13 socks. Now he's going to pull out 2 socks at random and find the probability that the first sock is black and the second sock is red. Okay, so a bunch of different ways you can do this. Since you are going to be using more of this later in the second part, because he's going to pull out 2 more socks, then it may be worth just going ahead and splitting it into 3 to start with. To say I've got black, red, and white. So the probability that the first one is black would be 3 out of 13. The red would be 4 out of 13. And the white would be 6 out of 13. And then from there, it could go black, white, red, or black, white, red, or black, white, red. Then you can fill in these. Right now there's only 12, and there's only 2 blacks left because you already took one of them. The whites, there's still 6, so that would be 6 out of 12. And the reds, there should still be 4, so that would be 4 out of 12. And notice 6 plus 4 plus 2 adds up to 12, so that looks all right. And then we go on and fill out the next one. So if the first one is red, then that means that there are still 3 blacks, so 3 out of 12. There's still 6 whites, so 6 out of 12. And now there's only 3 reds left, so 3 out of 12. And then the last one, white, black, white, and red. And so black again will be 3 out of 12. The whites will be 5 out of 12. And the reds, of course, will still be 4 out of 12. Okay, so this is going to allow us to answer all of the questions that we have left. Find the probability that the first sock is black and the second sock is red. So first black, second red. So there we go. Multiply 3 over 13 and 4 over 12. That will give us 12 over 13 times 12. In this case, I'm actually just going to go 12, and then I'm going to have 13 times 12. The 12s are going to cancel out, leaving me with 1 over 13, so I don't have to do too much work there. So I got 1 over 13 would be the first sock black and the second sock red. Puts the two socks back, so now we can use the same tree diagram again. Then once more pulls out 2 socks at random. Probability that socks are the same color. So same color would be, of course, the branches where the two are the same color. So I've got a 5 out of whatever 13 times 12 is there. And then I've got a red and a red. So that would be 4 times 3, which would be 12 out of whatever 13 times 12 is. And then I've got a white, white, of course, which is the 6 times the 5. So that would be 30 over 13 times 12, whatever that is. And we put all those together. We're going to add those together. So 30 plus 12 is 42 plus 5 would give me 40. Sorry, I did add there. Sorry, this should be 6. I know some of you are already saying that. Oh, I meant about it. He meant up. Yeah, I meant up, but I also fixed it. Okay, so 30 plus 12 would be 42 plus 6 is 48. So 48 over whatever 13 times 12 is. And I know 12 goes into 48 and leaves me with 4. So my final answer should be 4 over 13. And I think most people got that one as well. But there we go. Question number 3 is done. Moving on to question number 4. Numbers 0, 1, 2, and 3 are written on the 4 faces of a regular tetrahedron. Okay, so 4 faces, that's what a tetrahedron is. Even if you didn't know what the tetrahedron is, they told you that it has 4 faces. 1 number on each side. 2 such tetrahedrons are rolled, and the numbers on the bottom faces are recorded. So whatever is facing the ground. Find the probability that the sum of the numbers recorded is 6. Now, the easiest way to do this one, you could do a tree diagram, but that's definitely not the easiest way to do it. The easiest way is to do your sample space diagram like this and to write the sums in there as we go. So 0 plus 0, 0, 1, 2, 3, 1, 2, 3, 4, right? This is that one plus that one. And 2, 3, 4, 5. A lot of people did this, but some did not. This would be the easiest way to go about it. So the probability that the sum of the numbers recorded is 6. There's only one way to get 6 out of, you can count them up, 16 possible, because those are the dice, right? Remember, one die we put up on the top from 0 to 3. The other die we put over on the side from 0 to 3. Add them up, each of these boxes. This is that one plus that one. This is that one plus that one. And we went ahead and add them all up. And the only way to get 6 is if both of them are 3s. And so therefore that would be 1 out of 16 possible ways to do this. Okay. What is the most likely sum? Well, you can see that right here. If you've done it this way, you're done. You don't have to do any more work. The most likely sum is 3, and the probability of getting a 3 is 4 over 16, which of course is 1/4. All right, so not bad. Moving on to question number 5. Now this was a more challenging question. Okay, and this, definitely this was a harder question to work through. They gave you not a whole lot of information, and it's a 7-point question, which means there's some significant steps going on in there. All right, so what can we do with what we have? Events A and B are independent. A and B equals 0.1, and probability of not A and not B equals 0.45. Okay, so, well, I'm going to write down what I can, and hopefully I'll be able to use that later in order to be able to find A and B. Now, this one right here, I'm going to go ahead and just write it out. Because it is independent, the probability of A times the probability of B is equal to 0.1. Okay, I'm going to do that because I'm looking for probability of A and probability of B. So if I can write this in terms of that, then I think I'm doing pretty good. All right, so I went ahead and wrote that in. How about this one? This one's a little bit more challenging because this is both not A and not B. You know, if you can't figure out what it is, obviously you could, if A and B are independent, then the nots should also be independent, which means you could say, well, that means the probability of not A times the probability of not B equals 0.45. Now, the reason why I wouldn't normally think to do that is because we're not solving for not A and not B. Those variables are not very helpful here when I'm looking for A and B. I now have 1, 2, 3, 4 different variables, which really at this point isn't super helpful. I suppose you could rewrite it as you could go the 1 minus the probability of A times 1 minus the probability of B equals 0.45, like that. Sorry, I'm not fitting on my screen here. And then you would actually have two equations with two unknowns, and you would then need to be able to figure out how to work with that. You can't do solving linear systems. You know, what I would suggest, because the reason why I went through that process is because I want to teach you how do we approach a question, right? The not A and the not B are not helpful, right? We want it to be in terms of A and B. And so this is one way that I could do that, right? Now, of course, with this, because I have two variables, two unknowns, I could, you know, sticking with this, I could just say, well, that means the probability of A equals 0.1 divided by the probability of B. And so I could take this and put it in for the probability of A and then solve, right? I could just go in solve of 1 minus 0.1 over probability of B. I'm going to make my X. Yep. And then I need to put an extra parentheses in there. Times 1 minus X. And then that all equals, so I shouldn't have that other parentheses yet, equals 0.45, solve for X, and then close my parentheses. So that would be one way to answer this question, all right? What a lot of people did, and probably what I would have done, is I would have said, well, what is this probability of not A intersect not B? What would that look like? If I draw my Venn diagram, right, not A, if this is A and this is B, what area is not A and not B? So it has to not be in either of those, right? So that would be everything out here. Or in other words, the probability of not A and not B equals 0.45. That's the same thing as 1 minus the probability of A union B, right? Now that is helpful, okay? That's helpful because I have a formula. I have a formula that says the probability of A union B is equal to the probability of A minus the probability of B, plus the probability of B, minus the probability of A intersection B. And what you see here is that I can now solve for the probability of A union B, right? If 0.45 is everything on the outside, I can subtract the 0.45 this side, add the probability of A union B to this side, and I get the probability of A union B is equal to 0.55. So I can put that in. So 0.55 equals the probability of A plus the probability of B minus the probability of A intersect B, which we already know is 0.1. And then, as we did here, you can take this and put it in for the probability of A. And so you can go 0.55 equals 0.1 over the probability of B plus the probability of B minus 0.1. And that you can solve using insolve because you only have one variable. So again, we'd type in insolve, and then we put all of that in parentheses, and we'd say solve for, make this x, and then solve for x. And that would then allow you to solve it. Both of these ways should allow you to get the correct answer. Both should give you the same thing. All right? So, the answer you should get, by the way, is you should get two answers. The reason being is because these end up giving you a quadratic. X should be have two possibilities. X can either equal 0.25 or x can equal 0.4. Now, if that's the case, then B can be either of those. Now, you do have to be careful because insolve only gives you one answer, right? And so once you get the first answer, which is 0.25, you need to go comma 0. After the x, put another comma and say, well, check after this, 0.26, to see if there are any more answers, which there actually is. Now, if you don't get the second answer, you only lose 1 mark. Okay, you still get 6 out of 7 marks. But anytime you do an insolve, if it's not linear, you should always, always, always double check to make sure that there's not more than one solution. So if x, which is probability of B, is either 0.25 or 0.4, then you need to put that back in and solve for A. And so in the end, when you put the 0.25, put this back in for B there, you should be able to solve for A. Okay, once you solve for A, you should get that either probability of B equals 0.25 and probability of A equals 0.4, or probability of B equals 0.4 and the probability of A equals 0.25. All right, and like I say, even if you only got one of these and you solve for this right here, you'd still get 6 out of the 7 marks, which is pretty good. All right. Okay, that is question number 5, which was definitely the hardest question for most people. We'll move on to 6. Getting pretty close. This is our last question here. A group of 32 students went on a trip to Paris. When they returned, their teacher asked them if they climbed to the top of the Eiffel Tower, visited the Louvre, or took a boat on the river Seine. I have no idea how to say that, but anyway. The students replied as follows. 12 students did all 3. Lots of information. Draw a Venn diagram. All right, so here, Venn diagram. Here we go. All right, I've got Eiffel Tower. I've got the Louvre. And I've got the boat on the Seine River. Just like that. Now, what does it give me? It gives me that 12 did all 3. Well, that's nice. That was really nice of them because that means I already have this central number. If you don't have that central number, it actually makes the question 3 times harder at least, because now you need to find that number. Now it says 15 students climbed Eiffel Tower and took a boat on the Seine. So that's this spot right here. But Eiffel Tower and Seine is all of this, right? Even those 12 did both. It doesn't say only Eiffel Tower and the Seine River, right? It says they climbed that and that. So 15 would be both of those. So that means this has to be 3. So that adds up to 15. Okay, the next statement is 8 students climbed Eiffel Tower and Louvre, but did not take the boat. Okay, so this is a different thing because this gives us that 8 did Eiffel Tower and the Louvre, but not the boat. So that would be this section right here. Okay, because that section is both Eiffel Tower and Louvre, but it is not the boat section right there. And so that is 8. Okay. The last one is, what else do they give us? They give us 5 students climbed only the Eiffel Tower, so that's easy enough, only Eiffel Tower. 2 students visited the Louvre Museum only. and 1 took the boat only. All right. All 32 students did at least one of the 3 activities, so we know that 32 is the total. There is 0, so this total set should be 32. Draw a Venn diagram, done. Find the number of students who went to the Louvre and took a boat trip on the Seine but did not climb on the top of the Eiffel Tower. So, Louvre and river, not Eiffel Tower. So Louvre and river, but not Eiffel Tower. That looks like this blank spot right here. Okay, so that's the only blank spot, so we just need to add up what we have. So I got 12 plus 8 is 20, plus 5 is 25, plus 3 is 28, plus 2 is 30, plus 1 is 31, so that means I got 1 student left, okay, which then gives us the overlap. We then, let's see, calculate the probability that a student chosen at random climbed to the top of the Eiffel Tower. All right, so top of the Eiffel Tower is any student that climbed to the top of the Eiffel Tower, so that's all of these guys. Okay, so that's all of them except for 4, right? So that would be 28. You can also add those up, but 28 out of 32, which is 7 over 8. The next question is, did 2 of the activities, but not all 3? So not all 3, but yes 2. So 3, 8, and 1. So that would be 8, 9, 10, 11, 12. So 12 over 32, which would be, it looks like they're both divisible by 4, so that would be 3 over 8. And then visited the Louvre, given that he did only 2 of the 3 activities. Okay, so I'm going to write this out. So the probability that they went to the Louvre, given that they did 2 activities, only 2, exactly 2. All right, so this is going to be the probability of Louvre and only 2 divided by the probability that they did only 2. So the probability of Louvre and only 2, so that would be, how many are in the Louvre circle but also did only 2? Well, it's this guy and this guy right here, right? So that would be 9. And then probably that only did 2, we already counted those up. And so the only 2s were 8, 3, and 1, so 12, which gives us an answer of, those are both divisible by 3, so 3 over 4. Okay. Remember, this probability only 2 has to include all the students that only did 2. And then this one up here is the intersection of the Louvre and only 2, which these are the only 2 right there. Okay, the 8 and the 1. Lastly, a student chosen at random took a boat trip on the Seine. So given that they did the Seine, find the probability that she also visited the Louvre. Okay, so Louvre, given that they were on the Seine River. So again, this will give us probability of Louvre and the river cruise, all divided by the probability that they did the river cruise. And so L and S is this right here, so that looks like 13 to me, divided by the total of S, which is 12, 15, 16, 17, which is our final answer of 13 over 17. All right, and that's all the questions, that's all the SL questions from the quiz. I hope that video was helpful. I didn't do any things on the calculator because I think that you're already comfortable with the calculator stuff that you need for this. But if you have any questions about any of these, please do let me know. Please recognize that on question number 5 up here, I worked it in 2 different ways. You don't need to know both of those. Only one of them is needed. They both ended up using the NSOLVE, and they should both give us the correct answer. All right, so that's it for this video. Good luck, and let me know if you have any more questions.